All right.
No responsibility.
So you're just keeping me straight left or right. So it's A, B, C, D, E, F, G. So we can't follow that unload pattern. So our first class is a mix of U.S. pigment, silica, and some of the North Shore Michigan sand. We do have an 8-gram load of borate, so I'm expecting a lower viscosity. There also might be a little puff of smoke. Don't breathe that. It usually just kind of carries away with no problem. We've got sodium carbonate flux. We've got some pure calcium carbonate light powder, so that's actually a fairly high purity class. We've got a low cobalt, medium to medium high copper. So we're expecting a blue with a tinge of dark blue, which is probably going to tilt it a little bit purplish. Probably. We'll see. So glass A, pour it right there. So, are we ready for this? All right. So go ahead and strike the so a little closer, that's good right there. And focus more on the stream of glass coming out. Now fire polish that top part. You hit that little bump there. Right there, that's good. Okay, I think that's good. So now stamp it while it's still dark orange. Perfect. That's fine. All right, so that was good. Nobody died. Yeah, it's a lot of warm. So you'll also notice because this has copper, there's actually, because copper is so easy to reduce, there'll be some copper metallic particles that get entrapped in the top layer of the glass, which is left over from carbon monoxide in that flame. Partially, it's still combusting as it's hitting it, but some of that carbon monoxide on its way to carbon dioxide pulls electrons, or actually donates electrons to copper and reduces it in a surface film. So copper, because we're doing flame polishing, you'll always see a little bit of a copper brown mirror effect, and so if that only shows up in reflection. When you look through the glass, you wouldn't even see it. You may be tempted to want to play around with these stingers, but there's a reason I call them stingers. They can mess you up. They'll go right through your fingers. So after we get rolling here and get done, I'll be breaking all those off and stabilizing the edge of the crucible. But don't avoid this almost uncontrollable urge to play with fiberglass. It's still too thick, and so that makes it more like a hypodermic needle, or it just sticks right on you. It's awful. So anyway, next up we'll do composition 2, and this color will change. It's been slowly developing, and the colors will change as it cools until finally you'll get your final color within about 100 degrees from final temperature. But it keeps changing. So all right, next up is B3, so North Shore Michigan sand for every the whole
We're going to get a
amount. Sodium carbonate, calcium carbonate, so it's a pretty straight run there for that, and then it looks like 0.1 gram manganese oxide. So light purple is the expectation for this one. So B3, pulling from the left. And as you're using the torch, you always try to keep the flame off of the previous glass and especially off the previous row. So you're going to have to do some.
So for this one,
You're going to kind of angle it this way. Okay. And then once we start here, you're going to be angling back. So there's a little bit of nuance to it. So, all right. Pulling from the left. Good. Okay, looks good. Okay. Close your eyes here. So you'll also eventually hear a chorus of what's called crazing. And crazing is due to differential shrink rate, the coefficient of thermal expansion. Heard of it? Yeah. So in physics, it's differential shrink rates due to the fact that ceramic shrinks at different rates than glass, but the glass is brittle. And so as that happens, it will pull on the glass and get all these cracks. If you look down inside, you'll see every time you hear a sound, a new crack is popping, like ringing a little bell inside the glass. And so here in a moment, we'll have 12 crucibles all singing through the crazing process. You see it?
Yeah.
Yeah. They all do that. So even though this looks yellow right now, I think, at least I hope, will eventually flash to purple. But I've been surprised before. Sometimes you get a surprise color, but that's still pretty hot. So next one we'll put right here.
Crazy color check. Yellow and purple.
Yeah, that's why I'm starting to kind of wonder. But chrome will actually go brown to dark green. And so we've got an example of that coming up, I think. But we'll see. So next up, we've got composition C3. Oh, do I have C3? I don't see the paper. Boys, read off of here. We've got. You've got the paper. Okay, perfect. So I know it's silica, but I don't know what type. So we've got a purified Fischer. So that's 100 grams of high-end, 45 grams sodium carbonate, lower flux. Crushed limestone, bold move. That's the raw mineral right there. Low end, 20 grams. And you've got a chrome copper. So I'm expecting this to be a fairly high viscosity glass because that's high on the matrix former and low on the flux. So copper chrome, that's kind of medium green and blue, so that's going to be probably greenish blue. See what I did there? But sometimes you don't know, so we'll see what we end up with. So we'll pour here, and I'm expecting to be slower, more reluctant to come out of the crucible. So pulling from right. Plugs are smoking. So really towards the top of this when we're done, it's going to smooth. So really try to hit that top right here. Try to go on this side a bit more too. Back up a little bit. Okay, we gotta stop. So I don't know about that one.
Yeah, that's rough.
So there's a good chance in 20 minutes that one's going to explode. So,
Okay.
yeah. Now, in theory, and I have done this before, you can take ones that crack and you can reload them back in the crucible and you can refire them and heal them back to what they were before. So that one definitely was like, I'm not coming out. It's nice and warm in here. No thanks. But just in case, we'll pull a few measurements on that one. It might be fine. I've been surprised, but we've got. Let me melt my. We're about 57 by 60 millimeters ish by hovering. So that way, there's a place where you have to record that. That way, at least you have something to go by. Once give it a little more time, we'll probably put a beaker over that just in case. So the next one we'll put right here.
You want me to kind of hit it?
Yeah, so try to, what I've seen happen before is, nope, you'll be fine right there, but angle it so that the edge of the flame doesn't hit the side, because that can cause differential heating, and I've seen fire in here cause previous rows to crack. And so, yeah, explode isn't, it's a little bit strong of a connotation for what actually happens. It more shatters outwards, so it just kind of shoots straight off in this radial pattern and kind of sprays everybody. So just notice where I'm not looking. So yeah, I know it's been crazy. So pour right here. Safety first. So D3. So D3, you've got
right there.
the Michigan sand, borax, washing soda. So this is a borate, so low viscosity. 80 grams. This is a high flux with borax. This is going to be the polar opposite of that last batch. Calcium carbonate, manganese oxide, copper oxide. I think that one might stay yellow.
Yeah, I don't think that's true.
What the heck? You put a common stuff in it too.
It's weird. So manganese, copper. So that's our batch.
Can we dip on the
Center again. All right, so let's go for
That
it.
should get done. Yeah. I didn't even know that. Pizza.
Alright, I think that looks good. See how nice and flat? It just flattens right out.
It's good enough. You know, water too.
Yeah, sometimes that depends on the color, believe it or not.
Really?
Yeah, so some metals cause more radiant heat than others. So I'm going to go ahead and turn the extra hoods on just to get a little faster clear rate.
How do you know? Did like one crack develop or?
Just keep it in
That's not helping. Micro cracks. That's worse than doesn't help my time.
Yeah. That's definitely cool as well.
That's such a cool color.
And as those get up to speed, they might alarm here. So this will walk.
Yes.
There's the. Oh no, they're done.
I thought I saw one in the.
Doesn't exist.
I thought I saw one in the kiln that had.
I mean, it could be. It's just not on the sheet. They put it on the sheet.
It's like cobalt.
Alright, so now much faster clearance rate. It's kind of a gray-green at the moment. So we'll pour this one here. So now you're kind of tilting back this way. So that's I don't know if you use it, but yeah, we'll go ahead and move these down. Nothing's ready. Alright, so we Granny sills, the first time you've seen that one, that's a Michigan or a Minnesota sand mine out of Minnesota. There's silica deep sand, so it's kind of like Michigan is Minnesota. Washing soda, calcium carbonate, copper manganese. That's kind of a common so E3. Going from left. It's a tricky one too.
How do you know that you start doing?
Well, so you're heating the top. Bottom's already cool. So there's kind of limits to how long you can dwell on just the top. So if you had it like the opposite settling, you could light that thing up and just flatten out because you could push it past. But this one can't get. So if it's in an enclosure, you can make propane get up to this temperature. But in an environment where it's immediately bleeding off like this, you're lucky to get 8, 900. I mean, you have to kind of hold the heat to be able to get it there to a high temperature. So it's a losing battle for temperature the moment you're moving, unless you've got oxyacetylene where now you can push to 2,000. So in a commercial or a art shop, they have torches that they can dial into whatever temperature they want. Oh, those look really similar. It's surprising. Yeah. All right, so next. Yeah, it is. There is a difference, but they look similar shape. Yeah. So we'll the next one here. Maybe I'll get some preliminary measurements on that one too. Just because the small ones have a way of not surviving. 53, 54 millimeters by 60, 61 ish.
First number was 54.
Hopefully this microphone is picking me up, but yeah, 53, 54, it might. The small ones that have a tail that kind of slowly sinks in, that can result in some serious tension toward the center of the glass that just sometimes finds its way out. So it's now 54 by 60. All right, next up we've got composition. And that's U.S. pigment silica, sodium carbonate, calcium carbonate, right down the middle, line 90, 50, 25. Mid-range. Delivered chrome. So, expecting a medium to dark green glass, hopefully. So, getting space there. That's the reason you have to wear eye protection in here, so maybe those, you should have your goggles on. That won't fly. Thankfully, it went in that direction. But, all right, so I'm pulling right side.
Yours is definitely staying green.
So flexible.
More of a chartreuse.
To prevent that from going over, so it doesn't explode when I set it down there. Right, because it cools first, and so you can see the gradient from just hot blowing to I don't call it that. Yeah, you can see how that's now brown, that's chrome brown, but now it's going to turn this light green once it cools past that. That's called the flash zone. All right, so next up we'll put the next one right there. Composition G3. So Fisher pure silica, sodium carbonate, calcium carbonate. That's all reagent grade pure stuff. With 0.01 gram cobalt. That's a medium cobalt. So this will be a pure cobalt blue with no impurities. Well, with low impurities. So we'll put that in there. Going for middle. Look at that bubble. That's hot as can. Yeah, okay. That's a yellow flag on the play. That's it's got a big bubble on the one side, and I don't know where that's headed. That could be bad. This is experimental glass, so stuff kind of happens. Yeah, there's this big bubble, but then it got trapped underneath. We tried hitting it with enough heat to relieve some of that stress, but it might be okay. Yeah, it might be okay. Yeah, that's more. It's a really light blue. I think it'll darken. As it cools, but keep your eye on it. But right now it's almost like it's hot. So for this next one, we're pointing back in this way. It's kind of a bit of a challenge. So the good news is you've got a solid 15 minutes for that to do anything. Yeah, so hurry, right? So let's do the next one here. H3 sandbox sand, so that's a crowd pleaser there. 2 grams of borax, 47 grams of washing soda, This was kind of like the home brew crushed limestone with iron and manganese. So yeah, these are really common ingredients, stuff you could buy from Fleet Farm. Literally. So, kind of cool. H3 Fleet Farm glass. Put that right there. Four left. What is happening? Can't shake it out. I thought that would be clear than that. You're right. I'm not sure why that one is so thick.
There's not a lot of that guy.
Yeah, that was a lot thicker than I expected. But, so far we're doing alright, but none of these are like none of these are like sure things that you're gonna blow up. Yeah. So we'll do one here and probably the last one we'll do right there. So we only got two more left. So next up we've got I3. Silica beach sand, sodium carbonate, calcium carbonate, pure stuff. Manganese cobalt. So I3. About as good as you can get. Alright, one more. Before you stand behind unintentional human shield, you know? Person or flip flops and I found it was all once. I didn't see it till halfway through. I thought I was hallucinating, and I'm like walking over. It was old, busted out sand cast. It's like I just can't watch this. It's flashbacks. So one more. Put that one right there. These ones in the back are challenging because you might notice my gloves are smoking when I pull them out. So it gets kind of hot. So I think we'll still be on screen. All right, saying sodium carbonate, calcium carbonate, cobalt oxide. And this is the last one. J for Okay. Keep hitting that one. That might sink all the way back in. Probably. Some of these have a little curl on top. Nothing too bad. So that's the whole set. So far, so good. Good job. So this next piece, we have to wait a while for that to get cool enough to touch. We could literally cook on this surface up here right now. And I used to show if that's the case by spraying a little bit of, I put water right here. But one year, as I was doing that, a little drop went up, hit the top, and right, just thermally shocked right there, in there. Rip it off there. Alright, so I'm going to do up those two different approaches to glass. There's the artistic side and then there's the industrial side. So, Wes, thank you for your help there. Still a little bit left. So we definitely hold something off.
Oh, wow. That's so cool over here. Oh, I'm just sweating it.
That's one of the reasons that I cut the airflow is you do get a little bit off from these, but with all these hoods on, it's about the same as being outside. So, most of these ingredients are pretty, so, but yeah, there's definitely something that came off the flame at the bottom.
Okay, cold in there? Okay, cold in there? Okay.